So a little review of what we've done with these so far. The first thing that we always looked for, well, before we even looked for characteristics, we factored things completely. So we took our equation, and if there was something in the numerator we could factor, we factored it. If there's something in the denominator we could factor, we'd factor that as well. So sort of as a first step, this one in A, we would notice, hey, I can factor the bottom because it's a difference of squares. X minus 2, x plus 2. Once we had factored it, the very first thing we looked at were our non-permissible values. Because our non-permissible values either created vertical asymptotes in our graph or they created holes in our graph. So in this first one, if the very first thing we're doing is looking at our non-permissible values, our non-permissible values, x can't equal 2 and x can't equal negative 2. Now the question that comes up is, what are these? Are these holes or are these vertical asymptotes? And how do we know? They're both going to be vertical asymptotes, and the way that we know that is because neither of them gets canceled out with one of the factors on the top. If this on the top was an x minus 2 and it canceled out with the x minus 2 on the bottom, that would create a hole. But when things don't cancel out on the top or the bottom, they stay vertical asymptotes, and we can write the equations of these asymptotes. One will be x equals 2, the other one will be x equals negative 2. And we talked about this before as well. When we write equations of asymptotes, it's an equal sign. When we write non-permissible values, that's when we put the slash through the equal sign to say x can't equal 2. But the equation of the asymptote is with an equal sign. So the first thing we did was look for those asymptotes. The second thing we did is we tried to figure out if there was going to be a horizontal asymptote or if there was going to be an oblique asymptote. The way that we did this is we looked at the highest power or the highest degree in our entire function. Can you see in the first one that our highest degree is 2 and that our biggest power is the x squared? And so if we look at x squareds only, we have 1x squared on the bottom of our fraction, but we have no x squareds on the top of our fraction. And if we simplify this fraction, 0x squareds over 1x squared, we get 0. Anytime that this method simplifies to a number, that means you are going to get a horizontal asymptote. And the equation of that horizontal asymptote will be y equals whatever value you get from looking at that highest power in the numerator divided by the denominator. So we get our two sets of asymptotes, and we can start to graph. So as far as looking at the graph, I know that this one says just list the characteristics, but what section 2.3 and 2.4 are doing is setting you up for graphing. So I've decided to graph in 2.3, and we'll graph again in 2.4, and that way we would just get lots of practice with it all the way through. So we set up our graph, we draw in our asymptotes, we have 1 at 2, 1 at negative 2, and we have 1 at y equals 0. The next thing that we can look at is x-intercepts and y-intercepts. So as far as our equation goes, to find our y-intercept, plug in 0 for x. Can you see that if you plug in 0 for x, you'll get negative 4 over negative 4. And that's equal to 1. So we have a y-intercept at 1. You can label that point if you'd like. To find an x-intercept, we put y equal to 0. And one of the things that we've talked about is that a fraction, if y is equal to 0, so if I make this equal 0, the only way a fraction is ever equal to 0 is if the numerator is equal to 0. So the only thing we have to check is how would we make that x minus 4 equal to 0? And then we find that our x-intercept is at 4, 0, which feels weird because it's on an asymptote. So again, another thing to remember is that our vertical asymptotes are non-permissible values. That means your graph can never touch or go through a vertical asymptote ever. Our horizontal asymptotes are there to tell us what happens when x gets really big, either really big positive values or really big negative values. And so sometimes, as is the case here, we have our graph go through a horizontal asymptote early, like around the y-axis. But as x gets really, really big, we're going to find out that our graph's going to approach those asymptotes. So we only have one x-intercept. We have a point in 2 of the 3 sections, and we want to graph the rest of this. The only section we truly can graph so far is our middle section, because we know that our graph has to go towards our asymptotes. We know that there are no more x-intercepts. The only x-intercept is 4, 0. So going from this point, I have to go up towards my asymptotes, because if I would go down towards the asymptotes, do you see that I would get another x-intercept? And we only have that one x-intercept. Now, I have some problems in this section, so this section is done. I have some problems in this third section right now because I don't know from this point 4, 0, should it go up towards the asymptote or should it go down? Well, one way that we can find that out is we can plug in another value, say when x is equal to 3, and find out where that point's going to be. And once we find out where that point's going to be, then we're going to be able to say, okay, I know it needs to go either up or down, depending on that point. So if I go back to either my factored form of my equation or my original equation and plug in 3, can you see the top of my fraction will be -1? And 9 minus 4 will be 5 on the bottom of my fraction. So I've got -1/5, and I can now plug that in. That point's going to be 3, -1/5. And with this section, I know now that it has to be going down towards the asymptote in order to go through that. What's going to happen to the right of that? Well, the other thing we don't know if this graph is going to, maybe it bounces. Maybe it bounces off of our x-axis and stays negative. Maybe it cuts through and goes above. So I'm going to test another point at 5 and see where that point goes. So going back to my original equation, now 5 minus 4 would be 1 on the top. 25 minus 4 would be 21. And so I know that I have the point 5, 1/21. So my graph does go above the x-axis at that point. I don't know how high it's going to get. I'm not really concerned with how high it's going to get. But after it goes above, it'll eventually come back down and approach our asymptote. So there's sort of a little bump there after that x-intercept. The last section that we know nothing about is this section over here. You're going to find that when you're plugging in values in a section, you can plug in values anywhere. That's fine. But you're going to find that your numbers usually are nicer if you go closer to your asymptote rather than larger. So I'm going to choose 3 rather than choosing 100 over here or something. For one, the mental math is going to be a little bit easier because if I have to square 100, that gets pretty big. So when I plug in 3, on the top I'm going to get -1. Or sorry, I am plugging in -3 right now. So -3 minus 4 will be -7 over -3 squared is 9. 9 minus 4 is 5. So I get -7 over 5. So if I plug that point in, -3, -7 over 5. And now that I have that point, I know there's no more x-intercepts. I know that my graph has to approach my asymptotes. So this part has to go down, and this part has to go over. So kind of an interesting graph because it has that little, especially on the right where it goes through and has a little bump but then flattens out. But again, notice the pattern that we've done. We found our asymptotes first. Vertical asymptotes, horizontal asymptotes. Our third step, the main third step that we did was label our intercepts. X-intercepts and Y-intercepts. And of the ones that are probably the most important are those X-intercepts because sometimes you have to find other points, especially if they land on a horizontal asymptote. Once we found our X-intercepts, then we plot our graph. Sometimes we have enough information to finish a section like we did in the middle. Sometimes we need to add extra points in order to find out where this graph is going. And we had to do that in the first section with -3. We actually had to find 2 extra points in the third section. Okay? And it's not bad if you find even more. So if you're not convinced with the points that you have that your graph is right, find some more. Sometimes finding some more, you might find out you've made some mental math errors along the way. Like who hasn't plugged in numbers and accidentally added or instead of subtracted? And you could get a point in the wrong section because of that. So sometimes finding a few extra points can be good that way as well. Okay, let's look at example 2. I'm going to erase example 1 here. So part B, x squared minus 4 over x squared minus 9. First of all, there's a difference of squares on the top and a difference of squares on the bottom, so we can factor both of those. The first thing that we look at is our non-permissible values. Our non-permissible values in this one, x can't equal 3 and x can't equal -3. Those would be the values that would make us divide by 0. Are they going to be asymptotes or wholes? They are both going to be vertical asymptotes. We are going to get an asymptote at x equals 3 and x equals -3 because neither of those factors simplify or cancel out. Second thing that we look at is our other asymptotes. What is the highest power, highest degree in this whole fraction? An x squared. We have 1x squared on the top, 1x squared on the bottom. This simplifies to 1. That means that we will have a horizontal asymptote at y equals 1. Now we can start graphing things. At x equals 3. At x equals -3. And at y equals 1. Perfect. Now that we've got all of our asymptotes drawn, we can look at our intercepts. Again, our y-intercept is really easy to find. We can just plug in 0 for x. Plugging in 0 for x, can you see in the original fraction you'd have a -4 on the top and a -9 on the bottom? So that is 0,4/9. To find our x-intercepts, we plug in 0 for y, and again, the only time a fraction is equal to 0 is if the numerator is equal to 0. And again, this is why it's important to factor. It's important to factor in order to find out if something cancels out, to find out if it's a whole. But it's also going to be important to factor because once you've factored, you're going to be able to find your x-intercepts. And we have an x-intercept at 2 and at -2. So currently with what we have all the information in this middle section, and we're able to graph this. We have no information in either of the other sections. So the next thing we have to do is we have to try some test values. So we're going to plug in 4 and -4 and find out what happens. First of all, looking at the original equation, I want you to notice, do you notice that if you plug in 4 or -4, you're going to get the same answer? Because you're squaring that value both times. So when I plug in 4, I'm going to get 12 on the top, 7 on the bottom. If I plug in -4, I'm going to get the same thing, 12/7. Where is 12/7? Well, 12/7 is a little bit larger than 1, which is important because we now know that it's above that y equals 1 asymptote. And now that we have that point in that section, we know that it has to go, ooh, I wanted green. We know that it has to go up towards this asymptote and approach that asymptote there as well. Now, the one thing I just noticed as far as the list of things that we've done, in graphing it, we've done all of these things. Determine any non-permissible values. Well, we did that in step 1. Determine any horizontal or oblique asymptotes. We did that in step 2. What we didn't do was to say what the domain was for the first one or the second one. So we'll do the domain for the second one, and we'll do it in the simplest way. The way that you can write the domain when you have x values except for a couple of non-permissible values, you can say that the domain is x can't equal -3, x can't equal 3, but x can equal everything else. That would be the easiest way to write the domain. So our first one, what were our non-permissible values? 2 and -2. So you would say x can't equal 2, x can't equal -2, but x can equal everything else. Okay, we're going to do some practice with this graphing right now, 9 and 10.